Hello, and welcome to the Connected Places Catapult Impact Series webinar on the future of flight. Today's webinar, we're going to talk about the Future Flight Challenge projects that Connected Places Catapult have been involved in on the phase 3 of the program. The series is going to be recorded and we'll share it afterwards. And there is an opportunity for you to post questions on the bottom of the screen. And if we have time, that we will answer them live. If not, we will actually post the answers to your questions on our website. So welcome to the future of flight. Next slide. So the Connected Places Catapult, a few words before we start talking about before we start talking about the future of flight. We are the UK's innovation agency for transport, the built environment and for local growth. And we are part of the Catapult network, which brings together 9 leading technology and innovation centres which span right across the UK. We are an independent, not-for-profit private organisation, and we transform the UK's capability for innovation in sectors of strength. Next slide. So we are a neutral, independent and trusted expert convener. And our vision is better connected places across the UK, places that are more sustainable, regenerative and resilient with prosperous economies and thriving communities. And we work with our partners, that's right across government, both local and national, and with industry and with academia, to bridge the gap between innovation and the market, so that the opportunities of innovation can be adopted and scaled in communities, towns, and cities right across the country. And this work feeds into what we do into Future of Flight and our aviation work. Next slide, please. The Future Flight Challenge is a £300 million Innovate UK-led challenge which delivers a revolution in aviation by funding innovative projects across the UK. It positions the UK as a global leader in advanced aviation solutions, and it sets up working groups to tackle and discuss and solve the main industry issues. The challenge is working towards demonstrating the safe integration and operation of drones, advanced air mobility and regional aircraft advancements in electrification and autonomy. And it takes place over 3 phases. A £125 million investment is backed by £175 million from industry. Today, we're going to talk about the phase 3, the final phase of the programme, and the programmes that Connected Places Catapult are involved in. Next slide, please. So the 5 projects, we have my colleague Louise will talk about the Air Mobility Ecosystem Consortium. Tom will talk about CALUS. Tom will also speak about the In-Depth project. Then Richard will talk about the Sustainable Aviation Test Environment. And then finally, Lauren will talk about Skyway. So I'll hand over now to Louise. Thank you.
Thank you, Andrew. So my name is Luis Fernando Hageman. I'm Senior Urbanist here at Connected Places Catapult, and I'll be talking about the Advanced Mobility Ecosystem Consortium and the work that Catapult has been done over the last 3 years. Next slide. So AMEC, which is the term we use more often, is all about creating a sustainable and efficient air mobility ecosystem. As Andrew mentioned, is part of the Future Flight Challenge funded by Innovate UK, and we have about 10 between us and our partners, 10 partners developing a number of types of activities to support the air mobility ecosystem. While AMEC has a number of project focus, Connected Places Catapult work is focused on land use requirements for ground infrastructure, vertiports, and also to analyze the socio-economic viability of air mobility ecosystem, and as well supporting the demonstrating of flight testing with vertical airspace vehicle and support NATs and ATCANs to create an airspace that is fitted for the future. Next slide. So here we have a summary how we work over the last 3 years, and we're about to finish on the next quarter. So we started doing literature review to identify existing gaps in opportunities in this market. So what's already there about vertiports, how people feel about it, the supply chain, and all the players and stakeholders that already in this space. With that data, we did a statistical analytical data investigation to identify how we could proceed or who should we speak in more in depth to support us to understand how viable is the ecosystem today, but also what's need to be addressed to really make this ecosystem and the air mobility space futuristic and fit for purpose. And then we did some stakeholder engagement from local communities all the way to central government. And with that, we are work to create a market analysis and ecosystem benefits assessment, including how passenger services and how passengers would feel about, including disabled groups. And lastly, we are taking all this work and producing a number of reports. 4 of them will be made public early next year. One we will have is about all the summary of the project, but we have 3 dedicated reports that will be about the land use requirements and planning application. The other one will be about community engagement, and lastly about the impact assessment. Next slide. So here we have a brief summary of all the types of stakeholders we engaged over the last 3 years. And many of them we put together, we connect them as well. Some of them already work in the space, but were not aware of each one's work. So, but you can see that a variety of stakeholders and all different work packages we have engaged with the same or different ones in more in-depth levels, and more superficial level. Next slide, please. So AMAC is all about accelerating research and development and supporting the development of vertiports and eVTOLs over the next few years. So you can see the market is quite big. It's about $165 billion globally by 2050. And the UK is well positioned at the moment to support and take a good share of this market. So we are the whole project is about supporting a market growth, supporting the Civil Authority, Aviation Authority, and also DFT and the Ministry for Communities on creating all the regulation and certification needed to support the stakeholders and the market. We also aim to create interest from investors, logistic companies, aviation operators, also to really try to understand and make clear what the ecosystem needs to address to support the user experience, which is the most important part. So the users that will be using those services, as well to support local authorities and communities and the vertiport developers to understand all the requirements for vertiport development. So you can see, for example, why you have local authorities very at the heart of this process that handle those planning applications. If we don't have energy system fitted for purpose and with a lot of capacity, this is imperative for vertiport development. And lastly, have all this work is also, especially the reports and the engagements we did, is also to create an awareness of about the program, but also about the potential that the market and this development pose for the UK and for its stakeholders. Next slide. And just a little bit, Leslie here. So we are really engaged with the civil aviation authorities and also some government agents. And we also part of the Future of Flight Industry Group that unites a number of government and industry stakeholders. And we are supporting that development. And we are aiming that all these materials and research that we did will support achieving a technological focus, create a collaborative platform, also supporting the economic environmental impact assessment, and lastly, make the UK a global leader in this field. Next slide, please. So this is a bit summary of our project. Here's a contact of Marcel Poc, who is the technical lead of this project, and also my email that I led about the project on the land use and requirements for vertiports. Thank you. I will pass now to Thomas to talk about a little bit about Kalos.
Okay, thank you very much. I'm Tom Livermore, and I'm going to talk to you about Kalos, which is a project looking at medical drone logistics network for NHS Scotland. We have quite a large number of partners, and it's led by AGS Airports, and a key end user is NHS Scotland, who are one of the partners in the project as well. If you could move on to the next slide, please. So firstly, why medical drones in Scotland? So you might be aware that medical deliveries are being done by drones in other parts of the world. But Scotland in particular has a lot of remote, rural and island communities where people face long journeys to get to hospital services. There might be a hospital nearby to them, but it might not supply all of their needs. So often people have to travel to the big centres. So using a drone logistics network to bring some of those services closer to people and their homes, and avoid disruption to their lives and the other challenges that this brings. So there are lots of logistics challenges for NHS Scotland. If you can move on to the next slide, please. So the approach that we took for Kalos, we wanted to look at the full end-to-end service. So flying a drone from point A to point B, delivering medical items is core to the project, but we wanted to go beyond that and understand the ground infrastructure that's needed, how NHS staff themselves would be interacting, whether that's loading and unloading drones, whether it's ordering the drones, and ultimately, delivering the item to exactly where it's needed in the hospital. So that full end-to-end service. We also took a Once for Scotland approach. So all of the health boards that make up NHS Scotland were involved in some way in the project. And we had flight trials that actually covered 5 different health boards in the project. We also had partners who were looking at the airspace side of things, so understanding that there are constraints around how drone deliveries are undertaken at the moment, and looking at how airspace integration can happen in the future to unlock, ultimately beyond visual line of sight flights that will deliver what the NHS in Scotland need. We also spent a lot of time around engagement, so understanding public engagement to the idea of medical drone deliveries, also NHS staff, their views, positives, negatives about the service, both before and during and after the flight trials. And we also focused in on our partners looking at noise perception, because that was a key area that people had raised concerns around drones. And there was a lot of work that was done by Arup to understand the perception of noise in different environments and use that to guide how and where services will be developed in the future. Next slide, please. So in terms of the flight trials themselves, so we started with operating between a flight between Glasgow Airport and Golden Jubilee National Hospital, which is in Glasgow. We then moved to NHS Borders in Lothian. So this is delivering specialist lab samples into Edinburgh from one of the regional hospitals. There was also work done by one of the partners, the Scottish Ambulance Service, to understand how drones could ultimately in the future deliver defibrillators to emergency situations, and they were keen to understand how the public might interact with a drone to unload and use a defibrillator while being talked through by a call handler from their service. We then moved on to NHS Ayrshire and Arran, operating from the mainland over to the Isle of Arran, looking at blood products and lab samples primarily. And then finally, we've currently operating in NHS Grampian from Aberdeen to up in Dr. Gray's, which is in Elgin, looking at chemotherapy as one item. But all of these flight trials have considered a range of use cases, because ultimately there's lots of things that the NHS Scotland want drones to be able to do. We also looked at other opportunities and use cases that were simulated in a digital twin developed by the University of Strathclyde. So where we weren't able to fly for various reasons, they were able to simulate what those flights might look like and the impact it might have on those areas. Next slide, please. In terms of Connected Places Catapult, we did a number of activities within the project. So we looked at business modeling and developing a business case. So looking at the different commercial models for how a drone delivery service might operate in Scotland, and then developing a business case looking at specific use cases as examples for how a use case could be developed. And we developed that in a way that can be picked up by other health boards and other use cases. So that will be published shortly, and yeah, will be available for people to use as a tool for the future to understand the development of a business case for these types of services. We also undertook systems engineering work, so developed an operational concept for that end-to-end service, and try to understand what the requirements from an end user at the NHS would be, and then feed in validation activities into the flight trials and other activities to show that actually these requirements could be met where possible within the flight trials, and develop a technology roadmap for the future, what still needs to be done, and the different streams of activity that needs to come together. So this considered things like societal acceptance, regulation, aircraft technology, ground infrastructure, digital infrastructure to support, and also commercial aspects to fund scaling up this type of concept into ultimately in the long term a national drone logistics network that gives NHS Scotland what they need in all areas of the country. We also looked at the macroeconomic impact of such a service and building an ecosystem within Scotland that can support the service, the ripple effects of that into the wider communities, and looked at geospatial analysis to identify different routes within Scotland, understanding where things are currently moved between different health facilities and the appetite and opportunity in different parts of Scotland where drone deliveries could have the most impact. We were also project manager for the consortium as well, which had 16 partners. Next slide, please. So in terms of key findings at a very high level, I just wanted to highlight that there was a lot of enthusiasm for the idea. So our engagement with the public, we conducted surveys of more than 800 people responded, and overwhelmingly the response was positive when asked about the use of medical drone deliveries in Scotland. There's also a lot of enthusiasm from staff. Sometimes the enthusiasm was going beyond what we were able to do in the trials, and people were very keen to have a service long term, and you had to manage expectations, but that was a really positive message from NHS staff. And also government support for it, both at a Scottish and UK level. Government ministers have been engaged with the project and really keen to see it develop in the future. Next slide, please. Another key finding or area of key findings around the complexity. So I think the roadmap, which was published recently, shows how different strands need to come together for ultimately the service to be successful in the future. But also the impact and the value for money for a service. That was a complex picture as well. The work that we've done around the business case. The value for money ranges from very high to poor when you look at quantified benefits versus cost, and that's benefits that we could quantify within the project. So we think there's a lot more benefits that are left on the table, but ultimately it shows that there isn't a single answer for whether drones will be the solution to a problem in a particular part. You really need to understand the geography, the service as it currently stands, and what your actually use case, what you're using it for. The other key findings were around the potential. So I think the modeling and ultimately the flight trials themselves have shown that it has really significant potential. So for example, the flight trials that we did over to the Isle of Arran take on average 22 minutes to deliver versus 2 to 4 hours on a ferry route and road transport at either end. And yeah, that's a huge benefit for particular use cases for the Isle of Arran. We've also kind of highlighted the broader potential, not just the impact on the health service, but the wider society and also the economic benefits that come with embracing a technology like the drone delivery service in Scotland. I think there's one more slide just to wrap up and say thank you for listening. Here's a list of the partners and a website that you can go to for more information. And if you want to get in touch, here's my email address. So I think it's me next again to talk about a different project. So this is, take a pause for everyone to digest. This is the in-depth project. If you could move on to the next slide. So Phil Moorcroft is leading this project. So I'll show his contact details at the end if you want to get in touch. This project was led by BT, and we had two technology partners. Heratech 8 provide a drone in a box service, which I'll talk a bit more about. RoboK provides AI analytics, and that's applied to the data that a drone is able to capture. We also had two end user customers. So Associated British Ports run a number of ports within the UK, and we were based doing trials at their Ipswich facility, and Kia Highway undertake highway inspection and maintenance activities across a range of areas within England. And yes, the project was really interested in these two particular use cases where you can show real benefit to the use of drones, carrying out ultimately beyond visual line of sight missions to look at these critical national infrastructure elements and really understanding the value and commercial benefit of these use cases. If you can move on to the next slide, please. So this just illustrates how the partners come together for this project. So as I said, Heratech 8 provides a drone in a box service where you're able to request flights, and a drone situated, in this case, at the port, was able to undertake a mission to go and extract imagery and other asset information from a flight that you've requested. BT were providing a data platform that brings the data from the drone and provides it in a way that can be kind of digestible to users. And as part of that, RoboK with their AI analytics would take the information that came from a drone, whether it's imagery, whether it's video, and they were able to extract real insights from that. So people don't have to trawl through hours and hours of video or scroll through different images. They can extract what they really want to know from that. And I'll talk more about the use cases in a second. So yes, ultimately ABP and Kia were the end users of these, and we were working closely with their staff members to understand the use cases that they were most interested in, and the value that can be added to them as customers. Next slide, please. So here's a very brief summary of some of the use cases that we were exploring. So we had activities on the water, so looking at different floating assets and the use of the marinas that have berths that are either occupied or not, and keeping track of where different assets are on the water. But also on the land side at the port, understanding inventory and is everything in place it's supposed to be, how the land's being used, and whether assets are deteriorating, so buildings and cranes, etc. And then on the highway, so we used some of the roads within the Ipswich port as example use cases, and ultimately this is something that Kia Highways would want to be operating on public roads in the future. So we looked at carriageway safety inspections. So these are regular inspections that need to take place at fixed intervals, depending on the type of carriageway that you're looking at. And also detailed inspections where you've identified something and you want to go back and have a bit more detailed look and understand what repairs need to be undertaken, if any. We also looked at footway inspections. So the fact that you're able to fly a drone in this environment and capture information across all these use cases is an incredible asset for ports and road authorities to have. Next slide, please. So again, in terms of Connected Places Catapult's role, we looked at the market analysis to understand what else is going on in the world in relation to this and the use of drones in such applications. That report is publicly available, so there's a link to the website at the end if you want to have a look at that in more detail. We also looked a lot at the commercial model and business case, which I'll talk a bit more about. And we also did a piece of work around systems analysis to understand ultimately that data is of use to the end user, but there's various systems and processes that are in operation at ports and highways that ultimately that data would need to feed into. So setting a scene for what the future would be, where a drone could identify activity or an incident or a defect and feed that directly into the relevant system. So that end-to-end service again. Next slide, please. So in terms of the commercial modeling and the business case, so we worked very closely with the end users, and this was a real benefit of having the consortium makeup that we had. We were able to talk to them about how business as usual works in terms of how often things need to be inspected, how often you have to go out to incidents and look at things that are going on at the port and understand the costs associated with that. We then looked at the potential benefits for the drone being used in these use cases, and ultimately the costs as well from both the supplier partners who were in the project based on the commercial models that could be put together and understood for how this could operate. And ultimately we end up with some cost benefit outputs to understand the value of this type of use case to ports and highways. Next slide, please. So in terms of the key learnings, so I think it's really important to flag that we were trialing the use of the drone at Ipswich Port, and the project's now concluded, but the drone is still being used. I think that is a testament to the value that the end users are seeing from the drone information that it's providing. So yeah, it's a really strong case for the use of drones in these types of applications. And aside from the cost and efficiency benefits, there's lots of other kind of associated benefits that are highlighted: reduction of risk, emissions, and productivity. So yeah, it's a really kind of strong case for the use of drones. But there were barriers. So there's regulatory challenges around unlocking beyond visual line of sight at scale. So ultimately, the drone in a box solution, you would want to have that with limited human intervention or as little as possible for an efficient use case. And there are challenges still around that. So that would be something that the real potential of this would be unlocked with changes to the BVLOS regulations beyond visual line of sight lights. So we think, yeah, there's a lot of opportunities here. As I mentioned, the different use cases that were identified at the port and highways, ultimately they do start to stack up on top of each other and keep adding benefits. So one flight might actually solve lots of different problems. And understanding exactly how the commercial offering can be developed from the consortium partners going forward and how this is marketed in the future. But in summary, it's in a really strong place. And yeah, again, just to highlight, the system is still being used by the end user, even beyond the project. So that's a really, really strong sign. Next slide, please. So yes, there's a project website if you want to download reports and material that I mentioned, and Phil Moorcroft would be happy to take questions in the future when he's back from holiday. So yeah, please get in touch if you have any questions. And now I think I'll hand over to Richard.
Excellent. Thanks very much, Tom. Hi, everybody. Great to join you today, and thanks for the opportunity to talk to you about the SAPE project. So I'm Richard Tusting. I was the technical lead for Catapult's input into the SAPE project. Next slide, please. So just a little bit of context about the project. So What is SATE? Well, it's a sustainable aviation test environment. It has a facility which was delivered in the preceding SATE project, SATE 1, which is up at Kirkwall Airport on Orkney. SATE is based in the Highlands and Islands, which is shown in red on the map on the right-hand side. Along with the other projects today, it's part of the UKRI Future Flight Challenge, and the overarching kind of purpose of SATE is to sort of demonstrate emerging technologies in real world scenarios, and then looking at kind of environmental, social, and economic elements. So the sustainable in SATE being sustainable in all those, not solely from a environmental perspective. The lead of the consortium is Hitrans, has a kind of overarching role for coordinating transport in Highlands and Islands. Next slide, please. Thank you. So just so looking at the consortium, the sort of top right-hand side of the slide is the technology providers. So we've got ARC Aerosystems have got a eVTOL, and that's a picture of them doing a tethered test at the Kirkwall facility. Cormorant have got short takeoff and landing aircraft prototypes, electric ones. Hybrid air vehicles have got quite a funky looking offer there, as you can see. Wind Racers have been doing, they did some one or two different types of flight up at Orkney. I think one of which was with Royal Mail, but they've got remotely piloted or BVLOS technology. So there's a lot of very cool kit inside the plane, which is a relatively simple plane. All the clever stuff is the tech. And they've been or about to test. I think they probably have done some testing now up in Orkney. Flarebright have got some kind of telemetry in-house, in-aircraft type kit, which works without GPS. And then moving on to the kind of intermediary bodies, if you like, up in north of Scotland, there's EMEC, which is based in Orkney, and that's European Marine Energy Centre, and that's they provided input into the project, and they also kind of provide a kind of a helpful example of an innovation centre alongside the aspirations of it, SATE itself, from an aviation perspective. On the left-hand side, we've got the kind of the authorities, and also HIAL, which is the Highlands Islands Airports Limited, which runs most but not all of the airports up in that region, and they've been heavily hands-on involved in some of the aspects of getting regulation to actually allow testing in airspace, so working with the Civil Aviation Authority. So then on to catapult input. So what I'll talk about today is one element of what we did, which is a high-level demand model. We were looking at strategic elements of SATE, so the potential demand for services, and also the environmental and social and economic impacts. We also did some work and are continuing to finish off some work with the SATE Consortium and Hitrans in particular to help kind of think about and see how SATE develops in the future. Next slide, please. So onto the work itself. So I was going to talk about the modelling element. What were we trying to understand? Well, I've talked about the geography. Highlands and Islands was the primary focus, but we also in our modelling covered the rest of Scotland. In terms of technology, we were looking at kind of tangible near-term technology. So we're looking at retrofitted traditional aircraft. A couple of pictures there. There's one of which is ZeroAvia, which is a hydrogen fuel cell retrofitted aircraft. And then we're looking at the potential demand from the existing airport network, but also with quite a lot of these technologies, there's the possibility to start using different locations other than airports. So we needed to cover that within the model. So the purpose of the model was to look at the potential mode shift from existing private vehicle and public transport trips and people's propensity to use new flight services. And as I said, that's considering both existing airports and also potential new locations. Next slide, please. So just a little bit into the detail. So in common with most of the future flight projects, you're looking at across a range of different or the project as a whole was looking across a range of different use cases. For ourselves, so obviously there's goods there. So as Tom covered in Caylus, for example, that's like an example of a logistics or goods use case. Also, maintenance inspection was another. And then the other side was kind of people carrying, passenger carrying. So we ignored the logistics side and focused in on the movement of people. And then our key inputs into the model. So we spoke to Transport Scotland and got various data sets from their strategic multimodal model. We got origin destination information about trips within Scotland from mobile network data. And then we got some further smartphone information from a company called MBI, and that was really looking at attractions around airports. So seeing what trips would be attracted to the airports. Also carried out a stated preference survey, which I'll go on to in a little bit more. And then pulling all those together in the model, then it starts to allow us to do what ifs and understand potential mode shift and so on. Next slide, please. So again, just the another aspects of the model, so the zoning structure. So most of the rest of the UK outside Scotland were just dealt with trips at regional level. And then as you get into Scotland and into Highlands and Islands, it was more at disaggregated level, so intermediate zones, equivalent of MSOA zone structure. And then also the islands themselves, Orkney, and I think also Shetland, was then kind of disaggregated a bit further down. Next slide, please. So one of the data inputs I covered was the stated preference survey. So we had that carried out by a specialist company, and that just gathered information on understanding qualitative elements about people's current travel patterns and sort of attitudes, and also their propensity to use future flight services. So some of it was a mix of qualitative and quantitative data. The quantitative side, kind of a scale of 1 to 5 or 1 to 10 on various elements in order to provide calibration data to go into the model. Next slide, please. And then here's just a quick of a snapshot of some of the key survey results. So we can see there's a fairly high willingness to use future flight services, albeit what is presented to people, the kind of zero avia type technology is kind of fairly readily recognizable. So, but probably not necessarily surprising. And then ease and convenience and price were important. No huge surprises there. And then moving up to the top right, safety was a factor. Limited luggage allowance was a concern. I think that's come up a few times in some of the future flight projects, particularly with the smaller aircraft. And then looking at the benefits, people thought it would be easier to visit friends and family, or shorter and more comfortable to commute. Next slide, please. So just giving, this is just one example of some of the sample outputs that we got from the model. So this looks at from Kirkwall on Orkney down to Aberdeen, Thurso and to Wick. and it shows you, if we look at, I don't know whether you can see it, Terry, well, the numbers are a little bit small, but Thursday's probably got the highest demand there. If we look at the top, in the kind of future case or future base case, we've got 472 trips. And then in the future with the ZEF or zero emission flight example, we can see that of the baseline, about 50–60% of the existing baseline car trips have moved over to a zero emission flight service. So there was a bunch of these. There were kind of initial taster outputs, just to share with the consortium and to help them kind of understand the capability of the tool. And then this type of analysis can be done as more specific use cases emerge. Next slide, please. So just one other element of the project, which is kind of alongside the modeling. So we kind of developed a GIS app, which was put together in ArcGIS Online and shared within the consortium. And that the kind of purpose of that was twofold, was to gather together in one place relevant contextual information for the use cases across SAIT as a whole. So here, there's a few snapshots of various screenshots. So the road network, existing and other types of airfields, the rail network, also moving down a bit more, there's oil infrastructure, wind farm and energy infrastructure, and so on. So all those various elements that may be, that are of use in terms of use cases and understanding potential demand. More specifically, just sort of continuing the thread of what I've been presenting in the last few slides, we also brought across what the spreadsheet output that I showed you on the last slide. So that was also brought across the model outputs and effectively an interactive GUI, so that people could go online and have a look and have a nose around and kind of query things in a different way, really just to socialize the model and kind of give people the opportunity to think and have a query for themselves. Next slide, please. So sort of wrapping things up on this, what are the kind of conclusions in general? I think we've got a useful tool for high-level what-if analysis of future flight passenger carrying services. It covers the whole of Scotland, and it can be used to look at demand for any origin destination pair. It could be or can be tailored to different future flight technologies. Obviously, the one that I've shared is a more readily kind of available technology, but obviously the eVTOL type services are something new to people, so their propensity to use the technologies and the services may be markedly different, and that may affect projected demand for services. Another aspect which I remarked upon, we haven't covered logistics, but I think some kind of separate high-level model, similar granularity, to look at freight and logistics would probably be really useful, and it's something that we've separately out with this project, but separately been looking at it at CPC. So if others are interested in that, please do reach out. And just looking at the initial outputs, so the volumes and passengers are relatively low in the baseline demand, and also the methodology has some limitations to understand induced demand. If there are new facilities or trips attracted or generated, that's not considered within the model. There are high volumes like mainland to mainland trips, but that's really dependent on the speed with which people could get processed through at the airports. And last couple of points, the key variables, unsurprisingly, were cost, time and frequency. So obviously there's a lot of attractiveness and interest in all this new technology, and that's all very exciting technology push, but the actual cost, time, frequency, the sort of core reasons for use are still there, although environmental impacts were relevant to work trips. And in this particular area, Highlands and Islands, Scotland, we think that the business case will be driven by as much by social benefits, because there's limited levels of service with the current modes, and it's quite remote. They're quite remote areas. Last but by no means least, obviously, like every project, it's a team effort. So just on the right-hand side there are the members of the team, myself as tech lead, Hazel Willis, project manager. In terms of what we've presented here today, Alberto and Sandhya were the leads for development of the demand model, and Steve Lohman covered the GIS application. I think that's me. Next slide. Yes, thanks very much, everybody, for listening. I think I am now handing over to Lauren.
Hello, everybody. I'm Lauren Chamberlain. I am a senior systems engineer here at the Connected Places Catapult. I'm hoping that people can hear me. Excellent. I'm going to talk to you today about the Skyway project. Next slide, please. So the Skyway project set out with some really ambitious objectives, and that was to enable safe, commercial, automated, beyond visual line of sight flights and operations at scale. Now, there's a couple of bits baked into that, so let's break it down a bit further. Aviation is the safest form of transport in the world. And so by introducing new technology to be used in the UK airspace, it has the potential to impact on safety. So the project puts safety as its biggest priority. But also, other parts of this vision focused on making significant but incremental improvements to the UTM technologies and the drone operators' services, so that they could begin to commercialize their services and start providing services to their customers. Next slide, please. So how does Skyway go about doing this? Well, fundamentally, the project creates a sky superhighway that's a connection of different masts in a network with sensors mounted on existing or newly deployed infrastructure. And that super sky highway route provides a route that drones can operate with safe separation from each other and from other aircraft and other aviation users. Next slide, please. So how does the technology do it? Well, there's a sophisticated ground-based detection system that comprises pan, tilt, zoom cameras to give a 360-degree view of the airspace. And that's aided by computer vision technology to identify and spot airborne objects better than the human eye could do. There's a range of different radio frequency detectors as part of the technology used to detect things like uncooperative drones, and also a range of different electronic conspicuity sensors, including ADS-B as the sort of main one, but there are others also. Next slide, please. And so all of those sensors combine together to give us a real-time view of the airspace and provide this UTM display. And when I talk about UTM, what I mean is uncrewed aircraft systems traffic management display. So if I talk about UTM, that's what I mean here. And that UTM system gives better and new systems situational awareness to drone operators for seeing uncooperative and cooperative aircraft. And the drone operators, as part of the Skyway project, told us that having this system compared to their beyond visual line of sight, visually mitigated operations with spotters, it gives them more time to prepare for intruders coming into the, where their operations are, for instance, fast jets that come at high speed. And that's absolutely key to being able to upscale drone services. And having a UTM display means you've got a convenient way to end-to-end integrate your feeds and outputs from your ground-based detection equipment and display it on a map. And that gives you the real potential to avoid problems that potentially are coming on the horizon about adding more restrictions and further segregation to Class G airspace. And this might offer a solution that allows drones and aircraft to operate safely together without that segregation. Next slide, please. So this project was complicated and had lots of different aspects to it. So we, CPC, haven't done it on our own. And so I want to introduce some of the other project partners. So Altitude Angel provided the UTM technology and deployed some of the new infrastructure. We've also worked with 3 different drone operators from Skyports, Skyfarer, Hiratech 8. And we worked with RPAS UK as the industry's drone association. We also worked with different technology providers in the form of BT Group, Visgard, and Angoka. And last but not least, worked with different local authorities from Oxfordshire County Council, Coventry City Council, and Reading Borough Council. And those will be the organisations that ultimately implement some of this technology in the real world as we go forwards. Next slide, please. So CPC's work has focused on 4 key areas. Firstly, we led the work package on regulation and policy. And we'll have a bit of a deeper dive into that in a few minutes. But we also did some important public and industry engagement work, and that culminated in a report that's already publicly available, and you can find it at this QR code, which will be available on the slides afterwards, or you can go to CPC's website and search for it by searching for the Skyway project. We've also done some work analysing the market and working out how you'd exploit UTM and ground-based detect and avoid technologies. And most recently, we're wrapping up the work, doing some work on human factors, working with drone operators to understand how they should safely implement their technology in the real world. Next slide, please. So I'd like to dive into work package 2 and have a little bit look at our regulation and policy journey a bit further. Next slide, please. So the project started off in August 2022. And the first goal was basically to work collaboratively and really closely with the CAA to build and design a regulatory approach for these novel technologies that have not been used in the UK before. So that's what we did to start off. And that was really important because those systems are going to be used to provide an end-to-end service to customers. Next slide, please. Having worked out what we need to do, we then needed to do it. So we needed to build a consolidated safety argument that encompassed, on one hand, the operating safety case from drone operators to operate in the specific category using the remotely piloted aircraft system regulations that you can see there on the screen. And on the other hand, Altitude Angel developing their safety case for their UTM system. And both of those things combined together to create a joint integrated safety case that we'd submit to the regulator for authorization to go flying. Next slide, please. However, in February of this year, that close working relationship that CPC convened with the CAA basically identified that we needed to change our approach and slightly change tack. And that was because current ground-based detect and avoid and UTM capabilities were found to have to fit into the existing air traffic management and air navigation services regulations. This is a quickly changing environment. The CAA is releasing new policies that are impacting this, like the DAA policy or the UK specific operations risk assessment. So keep an eye on this space. It's an area that's changing very, very rapidly. Next slide, please. But CPC strongly believe that in order for UTM and ground-based detect and avoid to be successful in the long term, the UK needs to do some work and create a bespoke market design that really integrates those 2 key technology areas. Next slide, please. So that timeline and that journey was really revealing, and we found out a lot from it. I'd like to tell you a little bit more about what we found out. So next slide, please. So firstly, we pioneered a definitive legal stance with the CAA on how ground-based detect and avoid and UTM capabilities would fit into the UK legislative framework. And that was absolutely key. Next slide, please. We also, with our close workshopping approach with the CAA, we're able to have stakeholders such as the drone operators get critique and critical review of their solutions and their safety cases to make them better and give them a better chance of moving towards authorization in the future. And that process also yielded a whole raft of different documents, processes, procedures that will ultimately be really, really useful as a sort of a starting point and a foundation for any future frameworks that come into place that are needed to be followed for beyond visual line of sight authorizations. Next slide, please. And so finally, the process revealed also a need for greater government leadership in this area and for the regulator to really try and coordinate their different areas of expertise and their different departments in a cross-disciplinary way to address this problem. And that's really important because the UTM and ground-based detectable void needs to be tested in the real world and integrated for success. The UTM is a key piece of the puzzle and provides the avoid bit of many different detect and avoid configurations. And so it will be required in order to scale up, enable automation of these services in future, and to start moving towards one-to-many supervised flights. Next slide, please. So how can you get involved? Well, we'd really love it if you read our white paper when we release it in February of this year. It's going to be looking at some of the priority interventions that government and regulator should make to build the successful market in the UK. It's going to be looking at the collaboration that also needs to be done by those parties to build that successful market. And it's going to be exploring some evidence and examples from the Skyway project of the different legislative barriers that may be in the way. So yeah, please have a read of that when it comes out. But also, I would like to just mention the Law Commission's work and their consultation that's coming out in Q1 2025. We shared notes with the Law Commission, and their work is looking at the legal basis for air traffic management and ANS in the future, and with a specific focus on the UTM. That consultation will find its way in front of government when it's been responded to, where government have to respond and take on board the ideas that are proposed in it. So I'd really encourage everybody on this call, if you've got a vested interest in this area, or even you're just interested, please have a read of that consultation when it's published and have your say to help build the future of UTM in the UK. Next slide, please. That's all for me. Thank you very much for listening, and I will hand back over to Andrew.
Lauren, thank you very much indeed, and thank you everyone for joining us today. I hope you found it interesting and get a good feel for the breadth and width of the support that we actually brought to the 5 projects that we're involved in, particularly looking around the commercialization of this sector. As I mentioned at the beginning, this webinar has been recorded, and we will share that link with you afterwards so that you can watch this at your leisure. And we've managed to answer some of the questions that you very kindly posted as we've gone along. Those that we've not been able to get around to, particularly those at the end of the presentations, we'll provide a response to and send that with the link. Finally, we did mention a number of reports throughout the presentations today. You can find those on our website, those that are produced by Connected Places Catapult. So if you look at our website, you can find that there, plus all our details of all our other aviation work and all the reports and other details that we have there. For those that are interested, you'll also find a link to our newsletter so you can keep up to date with CPC activities. But for now, we'd like to thank you very much for joining us today, and goodbye.